All right, guys, we're going to continue with section 6.2 and chapter 6, which is transforming random variables. You're going to see that a lot of the stuff that we see in this section is very similar to stuff we saw earlier in the year when we dealt with the effects of multiplying and dividing, adding and subtracting on a distribution. So you'll see this example, and we'll go through parts of it in class as well to make sure that you understand what's going on here. We are asked to find the mean and the standard deviation. So I've written out the formula for the mean, taking each of our different values for x and multiplying times the probability, and then adding those together. Keep in mind that we can have the calculator get these values for us as well, both the mean and the standard deviation, by going to stat and edit, and then entering in L1 our values for x, which would be 12, 13, 14, 15, 16, 17, and 18. And then in L2, the corresponding probabilities for each of those, 0.25, 0.1, 0.05, 0.30, 0.10, 0.05, 0.05, and 0.15. And then remember, we go to stat, over to calc, and one var stats. And remember, when we're dealing with these types of problems where we have probability distributions involved, we have to make sure that we're changing our frequency list to L2 by going to second and L2. Then go ahead and hit calculate, and we'll get our mean or our expected value right here at 14.65 and our standard deviation as 2.06. Now, it is important that you show the work, as I've shown here, when you're getting these values, okay? Especially for the mean or the expected value. For the standard deviation, not as important, but I still would show the first few terms using the formula that is on the formula sheet. Now, what this whole section is about is, okay, now we're going to be transforming our random variables. For example, here we're multiplying by 50 times everything because it's $50 per unit for the number of units that you're doing. So if we're taking 12 units, that cost is going to be 600. And we're noticing how multiplication is affecting the mean and the standard deviation. And similar to what we saw earlier in the year, multiplying affects it all. So multiplying is going to affect your mean, your median, the quartiles, the measures of location, as well as the standard deviation, the interquartile range, and range, your measures of spread. So the measures of center and location, as well as the measures of spread, will be affected by multiplication. Keep in mind that standard deviation, interquartile range, and range can never be negative. So if we happen to be multiplying by a negative value, we just multiply by the absolute value. The shape of our distribution of our random variable here will remain unchanged. Now in our next example, we're adding something, okay? So now we're taking our values and we're adding something. And we want to know how addition affects measures of center and measures of spread. And similar to what we saw earlier in the year, okay, measures of center are affected by addition and subtraction, but measures of spread are not affected. They are unchanged. So your standard deviation, your interquartile range, and your range would be unchanged when we are adding or subtracting a random variable. We'll go through an example related to a linear transformation and what a linear transformation is in class. Okay, a linear transformation just means that you're transforming by both some type of multiplication and addition. Notice that the mean is affected by both the multiplication and the addition, but the standard deviation is only affected by the multiplication. And we'll go through this example in class. There's a bunch of pages in here that we're going to skip, but there are some really important rules to know that we're going through that happen during these pages, but we don't need to go through all these examples. And this is when we're combining random variables. So now we have two different random variables, and I want to combine them together. When we're combining random variables, for example, I know the mean SAT score, the mean math SAT score is a 500, and the mean reading SAT score is a 510. I want to know the combined mean, so I'm combining those two random variables together. When you're doing that, you can just add the means together. So that's what this formula right here is saying. Mu x plus y is just equal to the mean of your first random variable plus the mean of your second random variable. Similarly, if we wanted to find the difference between our two means, okay, the mean math SAT score is 500, the mean reading SAT score is 510. What is the average difference, or what is the mean difference in your SAT scores? You can just go ahead and you can subtract those two means together, okay? So you can do exactly what you think you would do in terms of the means. What you cannot do, okay, is with the standard deviations, okay? If we want to know the combined standard deviation of x plus y, okay, maybe the standard deviation in the math scores is 10 and the standard deviation in the reading scores is 15, you cannot just add those standard deviations together to get a combined standard deviation of 25. Instead, what you have to do is you have to use this formula right here. What you're really doing is you're adding the variances together, and then you're taking the square root of that. So I take my original standard deviation, I square it, plus my second standard deviation squared, and then I take the square root of that. So if my math standard deviation is a 10 and my reading standard deviation is a 15, I'm going to do 10 squared plus 15 squared and then take the square root of that. Similarly, it does not matter here, and this is where people get confused, if you're subtracting your standard deviation. So say we're doing a combined mean difference or difference between math and reading, and my standard deviations are 10 and 15. No matter what, when you're talking about the standard deviations, you still add them together, square them, and take the square root, okay? So make sure that you write down these very important rules for when you're combining random variables. You can just add or subtract the means when combining the random variables, but you cannot just add the standard deviations. You must add the variances, which is standard deviation squared, and then take the square root as shown in the formula here. Okay, so make sure that you write this down. Again, 10 through 13, we're going to skip. Following this, there are several examples that we're going to look at that deal with combining random variables, where we're describing the distribution between two random variables that we're combining. If you want to take a look at those and try and do them ahead of time before we get to class, feel free, but we'll spend time in class going through all of these examples here. That's it for today's lesson. Lots of examples to do in class. See you then.